Hi everyone, this is Vibhav and I'm going to be starting a new series of videos on this thing called direct mathematics. So, what I'm trying to do through this is to explain certain mathematical concepts, even the simplest of concepts like addition or subtraction or the existence of numbers as such, in a slightly different way, which makes sense throughout mathematics. It should make sense even in complex numbers. So, another thing I like to do is to remove any misconceptions that might come in while we are learning mathematics, and also I want to encourage this mathematical way of thinking, which is actually something once you start doing it, it's really wonderful. So as to why I'm doing this, there's just one reason, and that is that when you look at something like multiplication of the normal multiplication of integers or any rational or real numbers that we are looking at, we just say, okay, I take this and then I add it this many times and then it becomes this times this. So I take 3 and add it 4 times and then it becomes 3 times 4, which is 12. But then when you look at 3 times root 3, also it makes a little bit of sense. But when you look at root 3 times root 3, half of us might have been a bit... Okay, so when we consider something like an irrational times an irrational, it's not really easy to understand such thing, and it's harder for complex numbers. So you might come to decide and say, okay, root 3 is approximately 1.732 something something, and so I take 1.732 something something and then I add it some 1.732 times, meaning I add it one time and then I take 0.7 of it and then add it or something like that. You might be thinking along those lines for multiplication of irrational numbers. I don't say everyone is going to think like that, but there is a certain group of people who are thinking like that. But the problem is, when you take it to complex numbers, when you look at 3 plus 4i times 5 plus 6i, for example, you don't even know what you're doing over there. This kind of an approach of adding things a given number of times and calling it multiplication doesn't work there at all. So that's one of the reasons we have to define something even when we are teaching it to a first grader in such a way that it will tally with concepts which we are going to learn even in a postgraduate. So in this video, we'll be looking at 4 questions, or rather the answers to these 4 questions. So the first one of these is, what is a number? So actually this is quite a famous question and asked in one of those IAS interviews, and to which the person replied, numbers are countable entities or something like that. But I'd like to talk a bit more about that fact. So let's assume a shepherd is walking with his sheep. Actually there's quite a bit of thinking, or rather quite a bit of a belief, that numbers were found in these commonplace places, like a shepherd counting his sheep, or somebody counting how much rice they had. Rice is a bit hard to count, so how many silver bracelets they had or whatever, something like that. So numbers came up like this, counting whatever you had. And so there's a shepherd and he's counting how many sheep he has. He takes his fingers and he says, okay, I open out my thumb and that's showing that I have one sheep. And so he gives each sheep a certain number. What I mean by this is, he's taking his thumb out and he's saying, okay, this sheep is there. So I pull out my thumb and I say, okay, that's one sheep and that's this sheep. The thing is, he has to assign the thumb to that certain sheep. Why he has to do this is because, let's say 2 of the sheep go missing, and now he's counting the sheep, and he realizes that there are 8 sheep. But if he uses some random order to count the sheep, let's say he counts the sheep from smallest to biggest, but he uses his fingers in a very clumsy way. The first time he's counting it like thumb, forefinger, and then middle finger, and then ring finger, and then baby finger. But the next time he starts counting with his baby finger, and then he's counting a given sheep using a different finger in each occasion. But if he's doing that, he'll not know when he's counting the sheep when they're lost which sheep is missing. I hope you understand what I mean. So the thing is, numbers are in a way values assigned to certain things. They could be sheep, they could be silver bracelets, they could be table fans, they could be anything. So we're taking something and assigning it a value, and that value as such is called as a number. So 1, 2, 3 and 4 and all came up in such a way. Now this definition doesn't fail for complex numbers either. We'll look at complex numbers separately in another video, where I'll be explaining the entirety of properties of and the ideas of complex numbers. But we can say that suppose I call a sheep 3 plus 4i, it's not going to go against any rule. I can very well call it 3 plus 4i. So let's look at another thing here now. What is 0? So 0 has a lot of interesting properties. So 0 times anything is 0. Division by 0 gives you infinite quantities, or you could actually call it undefined quantities in a certain sense, and many other such properties. 0 power 0 is undefined, and so on and so forth. 0 power 0 is not undefined, it I believe is indeterminate. So this number has so many weird properties. And what is actually that number 0? So 0 is nothing but a starting point, a reference point from which you count the rest of the numbers. So let's say I'm walking, or rather driving, from Kashmir to Kanyakumari. So let's say I'm at Delhi now. How will I measure how much I've travelled? I have to obviously measure the distance from Kashmir, right? So Kashmir in this sense acts as something like a starting point for me, a reference point. Okay, so let's say somebody is walking along the number line and he starts from 0, because, or rather let's call the point he starts from as 0, because that's what we're actually doing in mathematics. And then now he's at 11. So it's very easy, because we know what magnitudes of numbers are as such. So we know 1 comes first, and then comes 2, and then comes 3, and so on and so forth. So now that he has travelled 11 meters, you can make sense of what you're saying by he has travelled 11 meters. But assume that 0 doesn't exist, okay? And then there's a person who's standing at 963. What do you say about how much he has travelled? You can't obviously say anything unless you have a reference point. And that 963 is defined as something which is 963 units away from 0. So that's the significance, and that's the reason, and that's the meaning of 0 as such. Okay, so the next thing, what is addition? So addition is in a certain way a shift of the reference point. Let me make clear what I mean. So I say 3 plus 4 is 7, right? So what I actually mean is, if I suppose that 3 is now functioning as the new 0, what would be the new 4? So let me make myself clearer. Earlier there was a number called 0, and there was a number called 3, and there was a number called 4, and there was a number called 7. So now I call 3 the equivalent of what was 0 earlier, and there was a number earlier when 0 was 0 that will be 4 when 3 is 0, and that number is nothing but 7. So this can be represented better visually. So let me get a quick sketch of that. Okay, so this is what I was talking about. In this diagram which I have highlighted now, we have the place where 0 is actually 0, and this represents the place where 3 is now assuming the role of 0. So over here we can see that the place which was held by 4 when 0 is the reference point is held by 7 when 3 is the reference point. And that's what we mean by saying that 3 plus 4 is 7. And this definition certainly extends to complex numbers as well. And the next question, what is subtraction, which is what we would have learned about after addition when we were in first or second grade. And the answer to that is that subtraction is actually nothing but addition. The thing is, what you're doing in subtraction is you're adding the additive inverse of some number, and while you're adding two numbers, let's say you're adding 3 and 4, you're shifting 3 to be the actual 0 and finding the position of the point, or rather let me make this clearer, you're shifting 3 as the new reference point, and then you're finding the point who take the position which was earlier occupied by 4 in this new reference system. So that's what you mean by addition. And when you say something like 3 minus 4, what you're doing is you're asking somebody what the position of the point which was the additive inverse of 4, which is nothing but minus 4, what the position of what point would be occupying the position occupied by minus 4 in the original system in this new system where 3 is assumed to be the reference point. So you're just basically taking the additive inverse and adding it. That's what subtraction is all about. So I hope you learned something new and I enjoyed this video. Thank you very much.